Hello, everyone. This is Team Marvel from CS6440, Fall 2023. We will be discussing our project, which involves an alcohol and tobacco consumption health tracker that we developed. A quick overview of our agenda. We will be doing an introduction of our team and our project background, talking about implementation and the research that we conducted. We will do a brief demo and then discuss future work. And on to Amadia.
So our team consists of 5 members. Madhya Anand, working as a full stack developer, Madison as a backend developer, Sushmita as a front end developer, Amber as a backend developer plus data analyst, plus life science industry SME, and the last one, Sudhanshu as backend developer. Over to Madison.
To reiterate, our project involved developing a patient-facing tobacco consumption management web app with population-level trend reporting. As our project has evolved, we have shifted our focus from centering the app around alcohol consumption to prioritizing tobacco consumption. This adjustment was necessary due to the data we were able to obtain.
On to Sushmita.
Yeah, so the motivation for our project was majorly consisting of 4 points. One being a choice of lifestyle that addiction to alcohol or tobacco is one of the major causes of preventable deaths in the US. And people are not informed enough about the repercussions of the choices they make. And we need a way to track their vitals, measurements, how much alcohol or tobacco they are consuming, and review the personal consumption and vital trends. And last but not the least, a way to correlate their personal situation and probability of the increased risk of health conditions by analyzing the population level trends.
Our solution is a health management tool that features a vitals and physical measurement tracker with trend viewing capabilities. It includes a tracker for alcohol and tobacco consumption trends. Our tool provides insights into the health implications of lifestyle choices while leveraging population-level reporting based on bulk for patient data. It also has the ability to correlate user profiles, observations, which stem from vitals data, physical measurements, and lifestyle choices, in order to predict the likelihood of developing specific health conditions. This approach is rooted in real-world data and helps offer personalized health insights for individuals. On to Sudhanshu.
For our implementation, we identified our project topic and opted to use Flask and React initially. Then in our next phase, we faced some difficulties finding data for alcohol consumption. So we still continued making progress on our sign up and navigation flows in the meanwhile. Then we found a data source on tobacco consumption. So we realigned and generated trend analysis based on that data. And finally, we completed documentation and testing and deployed our app.
Over to Amber.
So there are two core aspects of the application. One is user interaction and functionality related to tracking user profile, vitals, and alcohol and tobacco consumption and trending. But other important aspect is inferencing for individual users from population level trending, analysis for certain health conditions, which are aggravating because of the substance consumption. Well, there is kind of interdependency between these two aspects. We worked on it parallel to save time. With our original scope of alcohol data consumption, we looked at data from WHO and CDC and NHS and EHR databases, but we couldn't find relevant data in public domain. The WHO's alcohol consumption data actually is summarized as statistics at high level for each country and lacks individual population level details crucial for trend analysis. When we looked at the alcohol research group's survey data, it took very long time to get access to this via request process. After we got the request approved, we realized it comprises over 1,000 dimensions and it is excessively noisy and sparse. And basically it required a lot of analysis and cleansing and summarization, which was impractical for our project timeline. So we ended up kind of not using that data. We finally turned to the bulk fire data from smarthealthit.org, but didn't find alcohol use data in it. We found patient observation data on tobacco smoking. Tobacco smoking closely aligns with our project subject area, so we changed direction to align with this, and we obviously, worked with our the mentor about this. The other area that we research a lot is the fire patient observation and condition standards. The data from smarthealthit.org is in fire format. So we applied our learnings from course to research patient observation condition resources to dig and extract this data for trend analysis. We looked closely in low-ink code and the SNOMED coding standards to find relevant data and values we need. The other another area where we did a lot of research is basically the health conditions caused by tobacco smoking to find correlation between the patient profile, the observations, and these specific conditions which are caused by tobacco smoking. And we primarily use the lung.org for gathering this information. So I'll next time gonna go more into the demo and just quickly highlight the key functionalities of the application. So here's a quick demo for our applications with the major features. This is our landing page, and a first-time user usually has to come in and register himself. So we go to the sign up, we provide the information about the user, and user is Mike Laughlin. State of birth made up from 1960s. He's a male and gonna go single, and we make it mike.laughlin@gmail.com. This is email, and we set his password to password. And as the user signs up, it actually logs in the user by default and takes them to the dashboard, since we don't have any history for this user currently. So there is nothing that we see into our dashboard charts. A user can come in here anytime and actually update any of their profile changes. Like if the user gets married, then they can update their marital status and submit the data, and it gets updated. So there are two major, the tracking that the application provides. One is the tracking about their vitals and the physical measurements, which we also call observations in fire terms. And then second is the alcohol and the tobacco consumption. Here's kind of how they will add any observations. So let's say adding the heart rate for the user, and heart rate is around 24 per minute, beats per minute. And this is the observation taken, a few years back in 2014. So we add this info here, we add the observation, and at this point of time, the application has inserted this information against the user profile using the Flask APIs into the MySQL Server database. Similarly, we can continue adding more observations and kind of track this information. Similarly, a user can add the lifestyle information like alcohol consumption per day or the tobacco consumption per day. So let's kind of add 4 cigarettes per day for the user. And this is also from back in the day in 2014 when we are tracking the information. The application gives the flexibility to add the information from the history, as well as they add the current information over time. We add the consumption, and again, this is actually talking to the backend database and adding the information there. And if we come back to the dashboard, we will see some data here what we entered. Since this is our fresh user, we don't have a lot of data, but we can actually work with a user who has quite some data into the system. So we log out and we use a demo user, which has data entered in the past. So once we log in, we can see that John Doe is tracking their heart rate over time, as well as the observation, as well as the respiratory rate over time. And as vital signs, they also have his physical measurements like their height and their weight and the BMI, which is more calculated based on height and weight. Then also their alcohol consumption trends, as well as the tobacco smoking trends. You can see that, how over time this user was kind of a very high tobacco user, but he's kind of course correcting. Similarly, his alcohol consumption is going up and down over years. So this is this basically lets user track and be aware about their the physicals and vitals, as well as their lifestyle choices over time, and helps them making more self-aware decisions while choosing, having more alcohol or tobacco. But we also worked on run some population level trends for across a data set that we mentioned earlier. And we generated those trends and imported that data into the application. Those trends were run outside the application. And in this case, we are looking at basically based on the user profile, we are running the inference on that data to look at, for this particular user age group, how the different health conditions get impacted for a smoker versus a non-smoker person. So we can see that in general for this age group, and any smoking history results into kind of more chances to develop that condition. So that smoking history aggravates their situation. This basically helps user to understand what the severe conditions they can develop because of their smoking habits. We also have the same data available for all age groups, which is kind of more spread over here. Just for the demo purpose, we can also show that if I update the date of birth to a higher range, so that this user kind of goes back into a different age group, we will see that our population level trends have changed, because for the higher age group, our basically inference works on the population level trend to provide that information. So this is where we are on our application. And obviously there are a lot of improvements we can do in terms of features, as well as if we have more data available, that we can actually go further from there. So we would like to find kind of additional sources of data and work with large volumes of data to find tobacco smoking correlation with health conditions for meaningful inferences for individuals. So we worked primarily with the age group, but if or when more data is available for driving inferences, we can work with slicing data in more ways and combine these slicings to analyze specific trends for more granular sets in meaningful way. So we can use this more granular age grouping, apply additional gender groupings, or factor in marital status, or add heart rate, or add respiratory rate categories for inferences. Another idea that we can improve in is by running analysis based on amount of consumption rather than like binary categorization, such as smoker or non-smoker. This health project health conditions based on degree of consumption and give users impact of different degree of consumptions like high, medium, low, or like amount to the projected health conditions. We originally started the project with alcohol consumption as our primary use case, so we would like to go back to it for the data available from the alcohol research group, and we would like to analyze, cleanse, and summarize that data for trend analysis. And I think from the last point here, we also see an opportunity to integrate tracking of consumption and health conditions of the user to the data analysis done in real time, including user profiles and conditions. This will help include the data gathered across thousands of users using the application to contribute to the trend analysis, which would help improve and leverage their population level trends in real time across the user population. So I think overall, we think that our application is very useful at how it stands currently, but we can have quite some opportunities to improve and add more features depending on how we move in terms of adding features and the data available. That's for Team Marvel. Thank you.